Okay, in this video I want to continue with problem number 79 in this set, evaluating limits algebraically. Now 79 is one of those fraction problems. So we have the limit as x approaches 0, 1 over 2 plus x minus 1/2 divided by x. Again, our strategy for solving these type of problems is to multiply top and bottom by the least common denominator of the fraction expression in the numerator. And in this case that would be 2 times 2 plus x. And we multiply top and bottom by that. So when we multiply the numerator by 2 times 2 plus x, in the first term 2 plus x will cancel, we'll be left with 2. So the limit as x approaches 0 of 2. When we multiply negative 1/2 times 2 plus x, we're going to get minus quantity 2 plus x. And that's all over 2x times 2 plus x. Now we simplify the numerator, we end up with simply negative x. Again, over 2x times the quantity 2 plus x. And here the x's cancel. And at that point we can plug in x equals 0. We'll get negative 1 over 2 times 2 plus 0, or negative 1/4. And that's problem 79. Now for problem 80 we have one of the trickier problems, or not necessarily trickier, but it definitely has its difficulties. So we have limit as x approaches 2 of x to the 5th minus 32, and that's all over x minus 2. Now you should see that we really can't factor x to the 5th minus 32, and there's no radical there, and it's not a fraction that we can simplify. So we're going to have to factor that the way we would factor any polynomial degree greater than 2, and that is hopefully using synthetic division. Now we do have a clue as to what a root might be. We're hopeful that one of the roots is going to be 2. If not, then we're not going to be able to cancel x minus 2 in the denominator, and we will not have a limit at that point. So let's try synthetic division with x equals 2. Now our first coefficient is 1, but then after that we're missing the 4th, 3rd, 2nd, and 1st degree terms. So we're going to need 4 zeros in there as placeholders. And then we have a negative 32. So we can begin from there. We bring down the 1, times that 1 by 2, add the second column, multiply by 2, add the third column, multiply by 2, add the fourth column, multiply by 2, add the fifth column, multiply by 2, and finally we get a remainder of 0. And that tells us that 2 indeed was one of the roots of the initial equation, and if we were to divide the top by the bottom, what we would end up with, the expression would be, since we started with a 5th degree, the first digit there is going to refer to the 4th degree. So we have x to the 4th plus 2x to the 3rd plus 4x squared plus 8x plus 16. Now the good thing about that is that we can simply do direct substitution there, and it's going to turn out that 2 to the 4th is 16, 2 to the 3rd is 8 times 2 is 16, 2 squared is 4 times 4 is 16, 8 times 2 is 16, and then plus 16. That gives us 5 times 16, or 80. And that does it for problem number 80. Very coincidental. I'm going to go on to problem 81. We have the limit as t approaches 0 of sine of 3t over t. And the way we're going to do this again is we need to get a 3t in the denominator to match the 3t in the sine expression. And so I'm going to multiply top and bottom by 3. The limit as t approaches 0 of sine of 3t over 3t is just 1, and times 3 gives us 3. And number 82, we have the limit as x approaches 0, cosine x minus 1 over 2x squared. Remember our three important limits, the second of which is limit as x approaches 0 of 1 minus cosine x over x, and that's equal to 0. Since that's the case, then cosine x minus 1 over x should also equal to 0. But even when I break that down, I know cosine x minus 1 over x is 0, but I'll have to continue in the next video.